This is chapter 4-4, proving triangles are congruent by angle, side, angle, or ASA, and angle, angle, side. Please copy your codes. We're going to start with postulate 21. As I stated before, we do not necessarily want to remember the number, but the name. Angle, side, angle, ASA, for abbreviation. And that means if two angles and the included side of one triangle are congruent to two angles on another triangle and the included side, then the two triangles have to be congruent. Well, what does that mean or look like? Here we are. Alright. We have two triangles such that we have triangle ABC and triangle DEF. And angle, side, angle says the angle, the side, and then the angle. So I have an angle. The side must be in between the two angles. Okay? It cannot be such that I have here. Let's see if I can move it. It can't be angle, then angle, and the side. The side must be in between the two angles, just like I see the side is in between the two definition here. So there's my side in between. Angle, side, angle, ASA, and it must match on the other triangle for DEF, angle, side, angle. Okay? I could have also done this if I did a triangle. Say I had another triangle and it was congruent to these two. It could have been angle, side, and angle. Again, the angle here matches because there's one marker, one side here to match AC, and then the two angle match, angle C. And this is still angle, side, angle, as it is here on triangle DEF, angle, side, angle. Right? Again, the side must be in the middle of the two angles. Okay? It cannot be, and if I redraw, again I state, cannot be drawn such that I have an angle, and then an angle, and a side, or side, angle, angle. That doesn't work. Okay, the side must be in between. Right? Moving on, next postulate. And before I move on, I should say, if I'm writing a congruent statement, that means angle A, because of the one marker, is congruent to angle D, because it has also one marker. That's my angle for the ASA. Side, AC, is congruent to side, DF. Okay, and that's my side for the ASA. There's my S, my side, AC and DF, that are congruent. And finally, that last angle for ASA, or angle, side, angle, is angle C, is congruent to angle F. And again, to make that the last angle in the ASA, or angle, side, angle. Okay? When that's true, if I can prove or state that two triangles are congruent by an angle, side, angle, then that's automatically going to mean that triangle ABC is congruent to triangle DEF. Triangle ABC is congruent to triangle DEF. Remember, vertices must correspond to what's congruent. So if angle A corresponds to angle D, it must be in the same position when I make the congruent statement. Angle A to D, or vertex A to vertex D. Angle B is congruent to angle E. Okay? And even though it's not marked, B and E are congruent, I know that angle B is congruent to angle E because I just proved it by the statement angle, side, angle, or ASA. So that means the entire triangle is congruent, therefore meaning that angle B is congruent to angle E. That also means the sides are congruent. AB is going to be congruent to DE because I've already proved by angle, side, angle that the two triangles are congruent. And back to what I was saying, angle C is congruent to angle F, therefore they're in the same position in my congruent statement. And again, that's called a congruent statement. Now moving to the theorem, not postulate, but theorem, excuse me. Angle, angle, side, AAS, okay? And that says that if two triangles, basically, that means you have to have an angle, then another angle, and then a side. If two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of the second triangle, then that means that the two triangles will be congruent. What does that all mean? Well, here's the drawing here. I have again here triangle ABC, and it's supposed to be congruent to triangle DEF by AAS, angle, angle, side. Okay, how does that match? I have angle, and then the side, and same thing over here, angle, angle, side. It doesn't matter if you go clockwise or counterclockwise. Because if I had gone counterclockwise, then I would have seen that I have, okay, first side, angle, angle. And I know I don't have one. It's the same thing as angle, angle, side if I reverse it. Okay, so if you got side, angle, angle, these two are the same thing. Okay? That just means you probably should go, this time you should go counterclockwise instead of going clockwise. All right, so we have angle A is congruent to angle D for the first angle in angle, angle, side. The second angle in angle, angle, side is angle C is congruent to angle F. And then the sides that are congruent here, side BC is congruent to side EF. And if I can prove a triangle is congruent by angle, angle, side, then that means that both of these two triangles are congruent, same size, same shape. And I can write the congruent statement, triangle ABC is congruent to triangle DEF. So two triangles, and again, A is congruent to D, therefore they're in the same position. B is congruent to E, they're in the second position, and then C is in the third position with F because they are congruent. Again, and I automatically know that side AB is congruent to side DE because I've already proven that these two triangles are congruent by angle, angle, side. So once I prove they're congruent by angle, angle, side, that means that all sides are going to be congruent on the first triangle as well as the second, and all angles will be congruent once I've proven angle, angle, side. So we've just gotten two postulates and theorems today. Angle, angle, side, and angle, side, angle.